talk on this chapter vehicle electrification and hydrogen mobility. Last time we talked about the electric vehicle. And we talk about the different kind of batteries for electric vehicle, and also we talk about the hybrid electric vehicle. We said the market now is moving to the hybrid electric vehicle, in which we have regenerative braking that help in generating more, a kind of convert the kinetic energy that is used, actually dissipated in terms of heat on the braking system. We can just convert it into electrical power, and we can store it in a battery, and then it can help driving the car, so it can reduce the fuel consumption for the total fuel consumption for the engine in this case, and it can improve also the efficiency. And we said the market is now moving to the hybrid electric vehicle with regenerative braking and the small battery pack that does not require external actually recharging, and that should help actually in reducing the specific fuel consumption for the whole engine, and also it reduces the emission. Also, we talked last time about a more advanced type of hybrid electric vehicle, which is a plug-in hybrid electric vehicle, in which we have both internal combustion engine in addition actually to a battery pack that need actually external recharging. We talk about two kind of plug-in hybrid electric vehicle. We said we can arrange in this case the motor. We have electric motor that is actually powered by the electric current coming from the battery, in addition to the internal combustion engine. So in this case, we can just arrange them either in series. We can just put both of them actually together, or we can just put them in parallel. Both of them can drive the wheel of the car. At the same time, we can just connect to the internal combustion engine and the electric motor. Another design, which is the series design for plug-in hybrid. Plug-in hybrid, we have battery. This is a big battery pack that require actually external recharging in this case. That's why we call it plug-in, in addition to the internal combustion engine. The series one, it just split the internal combustion engine from driving the wheel. Just as the internal combustion engine will be running an electric generator to generate electrical power. And this electrical power can either go directly to the electric motor, which can drive the wheels, or we can just take this electrical power. If we have excess electrical power, we can store it in the battery, and later on we can use it in the electric motor. We say the advantage of this series design is that this engine, we just split from the driving wheel, so it is actually independent of the engine load. So when I need to run the internal combustion engine, I can run this internal combustion engine at its rated power in this case. So rated power, that means this is the best performance for the internal combustion engine in terms of the efficiency, in terms of power output, and also in terms of the emissions in this case. It can reduce also the engine emission because the combustion is improved at the rated power when the engine is working at its rated power. So we have plug-in hybrid, we have hybrid يا شباب. So just to keep this in mind when I tell you hybrid electric vehicle, just hybrid, that means we have regenerative braking that just use the kinetic energy of the car while the braking, and then it can convert it to electrical power. This electrical power is stored in a small battery pack. Just we don't have big battery pack because the electrical power generated is small in this case. We can just store it in the battery pack, and we have electric motor. This electrical power can drive the electric motor at low to medium speed. But hybrid electric vehicle يا شباب, the engine, the car itself cannot be driven only by the electric motor, because the generated electrical power from the hybrid electric vehicle from the regenerative braking is representing a small percentage of the power, and it cannot actually be used to drive the whole engine, the whole car. So the car should be driven by the internal combustion engine, but some help can be coming from the battery at low engine speed while the city traffic. In this case, we can use part of the electrical power in order to reduce the emission within the city. But the battery itself in the hybrid electric vehicle cannot drive the whole car. In this case, at any stage, even at part load or small running RPM, the car should be depending on running the internal combustion engine. But the battery are helping when we are driving inside the city. This is what we call the hybrid electric vehicle. Another advanced one, which is the plug-in hybrid. Plug-in hybrid, we have big battery pack in this case actually, and we have external recharging for this car, for this battery pack. It requires external recharging, and in this case we can just drive the car actually, or the vehicle, using the electric motor in this case. So in some situation like this series plug-in hybrid, in all situation actually the car is driven by the electric motor, but it depending on the battery charge. If the battery charge is at low level, then the internal combustion engine is driven at its rated power in order to charge the battery. Once the battery is charged, the internal combustion engine will be off, and in this case we have all the way actually the electric motor is driving the wheels of the car in this case. And this is the difference between plug-in hybrid and hybrid. Hybrid only, we just have regenerative braking and a small battery pack that can help at low engine RPM in order to drive the wheels of the car. طيب the hybrid electric vehicle يا شباب بتهاف يعني some performance characteristic, as we have some help is coming from the battery, some electric power is coming from the battery that can help driving the wheel at low engine speed to medium speed. So that means in this case we can reduce the size of the internal combustion engine. So smaller engine size can be used, and also the fuel consumption can be reduced, and in this case also the emission of the engine can be reduced in this case. Usually شباب the hybrid engine, the hybrid vehicle, and also the internal combustion engine designed for the hybrid vehicle, usually it is of a small size, and it is already designed to work on the average power or the average load. So if you want to have the peak load in this case, so you have to actually load on the batteries in this case in order to provide actually excess power that should drive the electric motor, and it can help in driving the vehicle. So usually the hybrid electric vehicle, the engine in the hybrid electric vehicle is of a small size because we have some help is coming from the battery, and also almost it is designed to work on the average power, not the rated power. And if I want to accelerate this car, then in this case I have to depend on the battery in order to boost the power in order to run at higher RPM. The hybrid electric vehicle in terms of warranties, they provide warranty for 8 years for 100,000 miles, or it can be 10 years for 150k miles, and that's a good for warranty in this case. The braking pads, usually it does not require any kind of maintenance, because the braking pad it requires maintenance because we just convert the kinetic energy, the inertia of the car while braking, we convert it is dissipated in terms of heat, and this heat actually just results in erosion, and that's why we have to replace the pads of the brake actually from time to time, and it requires maintenance. But in case of regenerative braking, when you just press the brake, in this case actually the clutch will just disengage the engine, and in this case the kinetic energy and from the driving wheel actually will be used to drive an electric generator to generate electrical power. So we don't have dissipation of heat in this case, and that's why the braking pad does not require maintenance in the hybrid electric vehicle. Also the batteries, one of the drawbacks is downsides actually of this hybrid electric vehicle, especially plug-in hybrid, which require big battery pack in order to change the battery. The battery is of high price in this case. You can look at a kind of $7,000. This is for the hybrid version by Toyota and Honda. But also there is something. Those batteries, the Shabab, for hybrid electric vehicle can run up to 180,000 miles, which is about, this is actually more than 250k kilometers. Okay, and for service more than 10 years. Okay, so it's already high price, but it is actually reliable. Okay, and also the engine does not require significant maintenance in this case. Hybrid electric vehicle, as we said, the market is now moving toward the hybrid electric vehicle because it downsize the engine size, we have some help coming from the kinetic energy, we can just use it to generate electrical power, so some help is coming actually from the battery, so we can reduce the fuel consumption, and also we can reduce the engine emission. And that's why I told you last time that the hybrid electric vehicle, the market now is just moving to the hybrid electric vehicle that involve both of them. We cannot say, Shabab, that the internal combustion engine will just disappear. We cannot say that because, as I told you, we are actually in this world, we are in need of every single source of energy, and the internal combustion engine will continue in use. Even there are expectation actually that by 2050, the hybrid electric vehicle will have most of the share of the market. It will be hybrid, not totally battery electric vehicle, or actually electric vehicle, pure electric vehicle. In this case, there is actually a competition in this case, and the fuel price will be subjected actually to some pressure in the coming time, and for the consumer, it will have actually a good price because it is subjected to competition especially from the renewable sources of energy like solar energy, wind energy. However, those energy is still at the stages that we cannot say they are in full competition with the fuel, because I will show you right now actually that still in 2019 the fossil fuel can provide about 80% of the energy consumption for the whole world. The total energy consumption is provided, 80% of it is provided from the petroleum or crude oil in this case. But its price, Shabab, for the near future, or even for the long term, the prices for the oil will not be have the big jump up to 100. We have seen more than $100 per barrel. But I think the current nowadays prices, I think it will go for longer time. We can expect this price to be fixed for longer time because we have competition from other sources of energy. But now the market, as I said, is just moving to the hybrid electric vehicle, in which we have both of them. We have internal combustion engine, and also we have the battery back in this case. If you look at the evolution of the hybrid electric vehicle, it started, as we said last time, in 1839. It was the first electric vehicle. That electric vehicle was not actually able to be recharged, but there was actually a lot of advances later on. As you can see, we have in 1905 we have a gas electric car, and Toyota started in 1997. This was actually a great breakthrough in this direction. Toyota started this with Toyota Prius, which was available in Japan. Now we can see actually Toyota Prius is available everywhere in the world. We have Honda Insight also in 1999. And we have also Honda is also Honda and the Toyota was leading actually in this field. In 2004, Toyota Prius, Toyota's second generation has been released also, and then followed by Toyota Highlander, and also Mercedes-Benz. It provided a version which is S400, blue hybrid car. 2010 Mazda Tribute, it was a crossover car. Also, it has been produced, and nowadays actually the market, we have a lot of them. They have been actually followed by many of version of the electric vehicle, hybrid electric vehicle. And now the market, as we said, is now moving to transfer fully actually to the hybrid electric vehicle. So in the near future, maybe 2030, I think we should find most of the share of the market will be the hybrid electric vehicle. And the hybrid electric vehicle now you can see, I think there are promotion nowadays on hybrid electric vehicle by Toyota. So this is Shabab, is a comparison here. If you can look here, this is a hybrid model for Honda Accord, and this is the non-hybrid version. The price actually for the Honda, the hybrid one, is about $32,695. This is the retail price, and the price for the non-hybrid one, which require actually normal battery, we don't have regenerative braking, so its price is a little bit low. It's about $29,000. So we have difference between the hybrid one and the non-hybrid one of about $3,600, exactly $3,600. This is the mean difference for the two versions, the hybrid one and the non-hybrid one. But if you look, we said this one, if you look here, the hybrid vehicle, it can cut actually about 70 kilometers per only 1 liter of fuel. But here, this one, this is شباب due to the help coming from the battery. Here is this one, it can run only about 12.75 kilometers per 1 liter. That means actually there is difference. This one actually has better fuel consumption, better brake specific fuel consumption in this case, and it consumes actually less amount of fuel compared to the non-hybrid one. And this should result شباب in fuel saving. Also, you need to refuel your car and you have to pay money for that. So when we have this difference, this is a kind of big difference شباب. It's a kind of almost 30% difference improvement in the fuel consumption. So that should be translated into money with time. If you look at the fuel saving, we can have on average, we can have a kind of fuel saving of about $12. And then actually, this is actually on a weekly basis. Per month, we can just have a kind of 52, and yearly, we can save about $630 per year. So that means actually we can just pay back this difference in the initial price of the two vehicles. We can be paid back actually after about 6 years of service. So after 6 years of service, you should have been actually refunded this difference in the fuel, in the price of the initial price actually of the car. And then also still this car will continue actually to have better fuel consumption. So the hybrid electric vehicle, they have excellent gas mileage as they are using actually less amount of fuel to drive the internal combustion engine. We have about 20 to 30%, as we said, about 30% better mileage. It can run here actually for longer distance per 1 liter of the fuel. Also, we do have fewer tailpipe emission as we have already reduced the fuel consumption and the engine size has been, downsized in this case. So we expect to have lower emission. It can reduce the emission of about 30%, the hybrid electric vehicle. It have also lighter battery because the battery in the electric vehicle, we have the internal combustion engine in addition to the battery. So in this case, the car itself does not depending on mainly actually on the batteries, like the case of battery electric vehicle. So in this case, we can use lighter battery and we have regenerative braking, which a kind of energy recovery. We recover the energy dissipation in the braking system. We can recover it in terms of electrical power. It requires less maintenance, as we said, and we have increased engine life. So for the hybrid electric vehicle, the car itself, it should have elongated lifetime compared to the non-hybrid one. Because in the hybrid, the engine actually, we have some help coming from the battery. So the engine also is not working at its rated, or excess power. So the engine lifetime actually is extended. The disadvantage of hybrid electric vehicle is we have reduced the emission, but still we are depending on the fuel. We have internal combustion engine, so we don't have emission-free system. Just we have reduced the emission. Also, it is a little bit expensive, as you can see here. We have said the initial price or the retail price is still higher than the other one, and we need some time in order to recover this money. Also, it is still we have to have some battery, so it should be a little bit heavier, and also battery require electric motor, so this will add to the weight of the car. Limited battery lifetime, as we said, after maybe, but it is not, we cannot say limited because the version in Toyota, Honda, those version actually, as they have been in service, only one battery can have, it can be in service for more than 10 years. And it can have actually more than 250k kilometers of running. So this is very good, and we expect to have more. Expensive battery, yes, batteries are still expensive. Safety issue due to the high voltage of the battery. So this is something we can work on because we have in this case high voltage battery besides the fuel. We have both of them. So it is easy actually to have a source of spark in this case that can ignite the fuel, and it can cause a kind of fire in the car in this case. So it requires more safety precautions. Also more complex, because in this case the computer controller, it requires to control the electric motor, and also to require actually to control the operation of the internal combustion engine. And we have also to match the operation between both of them. And also it is expensive to repair, because if you went to all the technicians there, everywhere need actually to know about this link between the electricity and also the internal combustion engine, and it has some little bit complication actually for the maintenance. But this, we expect this to disappear with time. Okay, but this is now, shabab, the market converting to hybrid electric vehicle. We are trying to reduce the fuel consumption, then we can reduce the engine emission, and this is the top target, that we need to reduce the engine emission, because we are actually under pressure. Some protocol and legislation has already been created. We have the Kyoto Protocol, which limit actually the engine emission, and put actually the car manufacturer under the pressure to limit the emission of the engine up to a given level. So the emission of any vehicle should be limited to a given level based on the Kyoto Protocol, which was signed between many nations under the United Nations in 1997, and this was followed by the Paris Agreement in 2016, that they agreed actually to limit the rise in the global temperature to 1.5 degrees Celsius above the pre-industrial level. So at the industrial level, it was actually, we can consider this as the reference. Now we have global warming. The temperature of the globe is already increased. We need to limit this temperature rise to 1.5 degrees by 2050. And in this case, this is based on the Paris Agreement, and we have, based on this case, we have to limit the emission of the carbon dioxide mainly, and the NOx emission at the lowest level, so that we can keep this 1.5 degrees Celsius by 2050. But I don't think this number will be kept the same. By 2050, it will be more than this, because this number, shabab, to keep it at this stage, starting from now, we should not emit any kind of carbon dioxide in order to keep it 1.5. But this is not the case, and it will not be the case. So but this is a kind of legislation and the protocols that we have to follow, and it put actually a lot of pressure on the car manufacturer in order to design the engine to result in a minimum level of emission in this case. We said this is the current situation. Is there any other alternative fuel that we can use for the vehicle? Yes, there are. Still, fossil fuel is dominating the energy production and the energy consumption in the world. This is 2017 report by International Energy Agency. Fuel is still providing about 80% of the total energy consumption in the world, and about 20%, other 20%, kind of 2.2 is coming from nuclear. Traditional biomass, this is a kind of 7.5, and we have 10% from the renewable sources, including solar, wind, geothermal, hydropower. All of this, this is 2017, shabab. A kind of 10% is coming from the renewable sources of energy. So still we are developing the renewable sources of energy. As we said, we can have the battery electric vehicle. This battery electric vehicle need to be charged with the electric current, with the electric power. This electric power we can generate from solar or wind or any source actually of renewable source. But still those renewable sources have lower share, or a kind actually is, you can see we can have a kind of 10% coming actually from the renewable sources of energy, but they are competing actually the oil, the crude oil, and this percentage actually is going to be raised, but the oil price is just going down. And when the oil price gets down, so this will delay actually the advancement in the renewable energy. So the advancement in the renewable energy is forced by the oil price. If the oil price gets high, then in this case we can just invest in the renewable energy, and its price will be comparable in this case. So usually the oil price is dominating actually the advancement in the renewable energy. But as we said, we are under pressure We have global warming issue, and we have to work on in parallel for both of them. We have to raise the share actually of the renewable energy. This is شباب the global fossil fuel consumption in 2017 based on the International Energy Agency. يعني we have a kind of 36% of the fuel consumption has been used in the electrical power production. But what we are talking about here is the transportation sector. It contributes to about 30% or 32% of the global fuel consumption. It's almost 1/3 of the total fuel consumption is consumed actually in the vehicles, in the transportation sector. Not only the vehicle, the whole transportation sector. And the CO2 emission, this was 2019. CO2 emission globally, we have about 80% of total CO2 emission on the planet is coming actually from the transportation sector. So now we have to work on this field for the vehicle, try to reduce the carbon dioxide emission. When the market now is moving toward the reduction, we can have two strategies, or the strategy in this case involve two approaches to reduce carbon dioxide emission. One of them is to reduce the fuel consumption. And this is what we are doing right now. The market is moving actually to the hybrid electric vehicle, trying to reduce the fuel consumption, and then we can reduce the fuel emission. But we need more. We need also to increase the use of low carbon alternative fuel. So we said we have a problem with carbon dioxide, global warming issue. So if we can use actually low carbon fuel like natural gas, I told you maybe in the first or second class that the world now is moving actually to the low carbon fuel. We can use natural gas in driving the electric vehicle, and the optimum case is that we can convert the crude oil, we can convert it to hydrogen, and then in this case we can burn hydrogen. Hydrogen is a very clean fuel, and it can result in only water vapor in the exhaust emission. And this is our target. We can just produce hydrogen or convert the oil into hydrogen, and then we can use this hydrogen actually to drive the vehicle instead of the higher hydrocarbon or normal gasoline fuel or diesel fuel in this case, to reduce the carbon dioxide emission. This chapter is a kind of mix. I just went to in different direction, but I'm just trying to link what we are talking about internal combustion engine with the recent advancement and about the future, just to give you a kind of insight about what's going on and what will be going on in the near future. Here, I just added this part. I know in chemical engineering you should have background in this. And mechanical engineering also should have background, but I'm just giving you just a short notification about the different methods that are used for the hydrogen production. Hydrogen can be produced from steam reforming. This is the main process for hydrogen production. We can use different fuel, but most commonly we use methanol, or methanol is not the most common case. The most common case actually is the steam reforming of methane or natural gas. This actually results in about 90% of the total hydrogen produced in the world is produced actually from this process, which is the steam reforming of methane. But we can have a steam reforming of any higher hydrocarbon fuel. We can convert any higher hydrocarbon fuel, methanol, ethanol, we can have also heptane, any hydrocarbon fuel. We can have a steam reforming reaction in order to reduce it to lower hydrocarbon fuel, or we can reduce it directly to produce hydrogen in this case. And this reaction is a kind of endothermic reaction. The steam reforming reaction is the reaction of water vapor, which is the steam, with the higher hydrocarbon fuel, which need heat actually in order to produce carbon dioxide plus hydrogen. The enthalpy of reaction here is a positive value. Enthalpy of combustion, which is the difference between the enthalpy of the product minus the enthalpy of the reactant, it is a positive value. That means the enthalpy of the product is higher than the enthalpy of the reactant. That means this reaction is an endothermic reaction. So it requires heat actually in order to have this reaction. And that's why we have to burn a part of the fuel. And it's almost a kind of 30% of the fuel has to be burned in order to generate the high temperature so that we can perform this reaction to produce hydrogen. But this process has high efficiency. It can approach about 75%. The molar ratio between water and methanol is almost 1 to 1.5 is required, and this process has to be done under high pressure, under high temperature as well. It has to be under temperature from about 250 to 360 degrees C in order to have this reaction. Once having this reaction, we can have combustion product, which is a mixture of carbon dioxide plus hydrogen. We need to separate this hydrogen. So there are two techniques. Either we can use actually the pressure swing adsorption. Pressure swing is that mean we have variation of pressure. So this reaction takes place at high temperature, at high pressure. So usually at high pressure, the gases actually stick to the solid under high pressure. So if we have solid substance, which we call it adsorbent, like zeolite or activated carbon, under this high pressure, actually those material can just absorb this hydrogen and they can separate it from the carbon dioxide. And then we can just reduce the pressure for this material. Then at low pressure, it will release the absorbed hydrogen. So we can absorb hydrogen at high pressure while the reaction is taking place to separate it from carbon dioxide. And then we can lower the pressure later on in order to release this hydrogen. Another way, Shabab, is the use of membrane. Palladium membrane actually are very effective and they are selective for hydrogen. So when we have those combustion product, when we pass them through palladium membrane, then this palladium membrane is selective. Actually, it have vacancies in the lattice structure of palladium. It can absorb the hydrogen and then it can separate the hydrogen from the carbon dioxide in this case. So this process, Shabab, reforming require endothermic reaction, require some heat, and also we need post-processing process in order to separate the hydrogen in this case. Another process for hydrogen production, which is the thermolysis process, which is the electrical water splitting, or water splitting actually by using the electrical power, in which we can separate hydrogen in the water, H2O to H2 and O2 using the electrical power. So we need source for electrical power in this case. And this process also, Shabab, it does not require heating. But if we heated up this process, if we heated up this water, this actually should improve the hydrogen production in this case. So also it requires heating in addition to the electrical power. And in some cases, they can use the urine instead of water, because usually water, nowadays actually water is a big issue, because actually the increased number of population and water is not available everywhere in the world. So in some cases we can use actually other liquid like the urine. And many actually of hydrogen processes or hydrogen need actually in the industry are depending on this process. But this process, Shabab, is a kind of it can be used as a kind of energy storage, because in this case we just use electrical power in order to produce hydrogen, and then this hydrogen will be used again to produce electrical power. So it does not have a meaning, because we have to have actually each of this process should have efficiency. So at the end, actually the final energy that we have in hand will be lower than the initial energy, which is the electrical power. But this is a kind of energy storage. If we have excess electrical power coming from renewable source like wind energy or solar energy, then we can use it actually to split water through electrolysis process, and then we can save the hydrogen to be used later on in different applications. So it's a kind of energy storage. The most common process for hydrogen production is the steam reforming of methane or natural gas, in which we can convert methane, we can convert it through the reaction with water vapor. It can be converted to carbon monoxide plus hydrogen in this case. This reaction is endothermic, as we said, but it requires high temperature. It's about 1000 degrees C. This is the temperature. and also in the presence of catalyst. We may have nickel in this case as a catalyst in order to improve the reaction or enhance the reaction between methane and water vapor in this case. This reaction يا شباب this is the production of hydrogen, as we said. But يعني hydrogen is not an easy gas to handle or to deal with. So if we need to convert hydrocarbon fuel, convert them to hydrogen, and then we can export this hydrogen, like here in Saudi Arabia, they are exporting hydrogen. Aramco started exporting hydrogen, but they export it actually in the form of ammonia. So we can have this hydrogen to be used actually in the synthesis, actually react with nitrogen. It can react with nitrogen to produce ammonia, as ammonia can be liquefied and it can be stored easily compared to hydrogen. I think Aramco started already exporting this mainly to Japan to export the hydrogen in the form of ammonia in this case. Here, this is the steam reforming reaction. But as you can see, here we have carbon monoxide. Carbon monoxide is highly reactive and it is a toxic gas actually. So we need to add another reaction. This other reaction, we call it the water gas shift reaction, which is exothermic reaction, in which we can have CO. It can react actually with H2O. Then we can convert this CO, we can convert it to finally to carbon dioxide plus hydrogen in this case. So at the end, we have a mixture of carbon dioxide plus hydrogen. Then we can separate the hydrogen either through the pressure swing adsorption, or we can use actually membrane to separate hydrogen. Then finally, we can convert the natural gas or methane. We can convert it finally to hydrogen, which is a very pure fuel. We can use it actually to drive the vehicle. And in this case, it will result actually in H2O emission, which is a very clean emission or very clean combustion in this case. This process is also efficient. So we can convert, it can have fuel conversion efficiency up to 65, from 65 up to 75, up to 75% in this case. Okay. So those are the processes that we can follow in order to produce hydrogen. Either we can have reforming, steam reforming of hydrocarbon, or we can have water electrolysis or water splitting in order also to produce hydrogen. Then we can use hydrogen as a fuel in this case, which is a very clean fuel. So the hydrogen pathways or the production technique, either reforming. This reforming can include the crude oil, so like the steam reforming of methane or any hydrocarbon fuel. Also, we may have cool gasification process. We can gasify the coal to produce syngas, and then also we can do the reforming process with water. Then we can produce hydrogen. Most commonly, we have most of the hydrogen production is coming from natural gas reforming or steam reforming to produce hydrogen. Also, hydrogen can be produced from the solid waste. Solid organic waste. It can be coming also from the wood, biomass. All of this solid fuel through a reforming, gasification, and reforming process, we can produce hydrogen in this case. Also, it can be from the electrolysis process. Electrolysis, we need electrical power. So electrical power that we can generate either from nuclear source, solar, hydro like the power of water in dams or something to generate electrical power through using hydraulic turbine, or through the wind, wave, geothermal energy. All of this energy we can generate electrical power, and then we can store it through the electrolysis process, store it in the form of hydrogen in this case. At the end, Shabab, we have this hydrogen. This hydrogen have per kilogram. It is highly reactive fuel, and it have actually a heating value of 142 kilojoule per kilogram, which is much higher than compared to the gasoline, which is about 48. So almost actually it's 3 times the calorific value or the heating value of gasoline. But this heating value, Shabab, is per kilogram. And to have 1 kilogram of hydrogen, we have to have actually very big volume of hydrogen in this case. So the volume of hydrogen, it is low density. It is actually the most light fuel in our nature, which is hydrogen. It is very light fuel with very low density in this case, and in order to have 1 kilogram, we have to raise the pressure of the hydrogen too much. So in this case, شباب, we have to have a lot of hydrogen in order to have little bit work. So if I use this hydrogen in internal combustion engine, that will be a big issue. In this case, I have to raise the pressure of hydrogen actually to a very high values, and in this case, so that we can store a reasonable amount of hydrogen. Then it can drive the vehicle for some time. But internal combustion engine, شباب, if you remember, we have calculated the brake thermal efficiency, and we said the brake thermal efficiency for internal combustion engine is about 30%. Only we can benefit towards 1/3 of the total fuel energy coming into the engine, and we can convert it into work. And also, if I use the hydrogen in internal combustion engine in the combustion process, this hydrogen is oxidized or burned in the air, and the air is containing nitrogen. And the high temperature combustion of hydrogen will result also in NOx emission in this case. The nitrogen in the air under high temperature combustion of hydrogen will be dissociated, and it will react with oxygen, and it will result also in NOx emission. So if I use the hydrogen in internal combustion engine, I have to be able to pressurize it to high pressure because it have a big volume under normal pressure. Also, when we use it in the internal combustion engine, it will result in efficiency about 30%, and also it will result in NOx emission. So there is another route, شباب, for using hydrogen, which is the hydrogen fuel cell. So the fuel cell is a device that can be used to convert the chemical energy of the fuel. We can convert it into electricity, and we can produce water also, and some heat can be produced due to the chemical reaction of hydrogen with the oxygen in this case. Hydrogen fuel cell is similar to the battery, but it is not a battery because we have a reaction in this case. But this reaction takes place at lower temperature. Almost it is less than 1000 degrees C. So in this case, we don't have emission of NOx, and in this case, we don't have combustion of fuel. Just we have a simple reaction of oxygen and the hydrogen to generate electrical power. And that we should not result actually in pollution or environmental issues in this case, because the hydrogen produced in this case, the hydrogen which is consumed in the reaction with oxygen, the reaction takes place at lower temperature, so it does not result in NOx emission. And also this process, شباب, can result in efficiency much greater than the internal combustion engine. The efficiency of the fuel cell, it can be approaching about 80 to 85%. So it's much better actually to use the produced hydrogen instead of burning the hydrogen in internal combustion engine. You will get efficiency of 30%. If I use this hydrogen in a fuel cell in order to produce electrical power, and then using this electrical power, we can drive an electric motor, and this electric motor can drive the vehicle in this case. This process in the fuel cell can result in efficiency of about more than 80 or 85%. In this case, we can get from the total fuel energy, and we can convert it to electrical power, and this will result actually in creating no pollution in this case. We said fuel cell is similar to the battery, but it is not a battery. Just it requires actually constant supply of fuel, which is hydrogen plus oxygen, and this reaction will take place, and it can result in generation of electrical power. This fuel cell, شباب, it does not require recharging like the battery. Just it need actually constant supply as long as we are supplying hydrogen and we are supplying oxygen. So the fuel cell will be operating in this case. Fuel cell was used in the first time is in 1838 by NASA in I think in the Apollo. They have used this version of fuel cell for the electrical power production in the space, electrical power and water production in the space. They produced the hydrogen and then produced the electrical power. They used it in electrolysis process in order actually to produce clean water in the space. This was the initial use of the fuel cell. If you look at the part of the fuel cell, شباب, Fuel cell يعني looks like the battery, but it is not a battery because it includes the reaction of hydrogen plus oxygen. It consists of anode. Anode is the negative post of the fuel cell, at which actually in the presence of catalyst, usually the catalyst used in the fuel cell is a kind of platinum powder, which can result actually in ionization of hydrogen to produce hydrogen ions, positively charged hydrogen ions plus electrons. This is at the anode side. At the cathode side, also in the presence of the catalyst, oxygen, the provided oxygen from the air, it can be also ionized to be negatively charged oxygen. And then we have in between, we should have the electrolyte. This electrolyte can be liquid or it can be solid. The most common one, which is used actually for fuel cell for electric vehicle, is the solid one, which is the proton exchange membrane. It's a kind of membrane. This membrane allows a transfer of the positively charged hydrogen ions, which has been produced at the anode. It allows a transfer of hydrogen ions through this membrane to the cathode side, where we can have actually the oxygen ions, and we can have the reaction of hydrogen plus oxygen to produce the water vapor. But if you look at the anode here, Shabab, at the anode we have here in the presence of catalyst, hydrogen is ionized to produce hydrogen ions. Those hydrogen ions can be transferred through the membrane, which is the electrolyte, can be transferred actually to the cathode side to react with the oxygen, and then it can result in water vapor in this case. But we have produced the electron from the ionization process of hydrogen. This process will also result in electron movement. This electron cannot be actually moving through this electrolyte, which is the membrane. So the membrane allows the hydrogen to pass through the electrolyte, but actually it looks actually the transfer of the electron. So the electron we can just take them from an external electrical circuit. Then we can use this electricity actually in order to drive the electric vehicle, or we can store this electrical power. We can store it in the battery, and then we can use this power from the battery to run the electric motor, and then we can drive the vehicle in this case. So we have the ionization process, Shabab, at the anode. The hydrogen ion will be able to transfer through the membrane. It will allow the transfer of the hydrogen atoms to the other side, which is the cathode, where we have the oxygen ions. It can react, actually they can react together to produce H2O, and some heat, Shabab, for this reaction of H2 plus O2. This reaction, Shabab, is exothermic reaction. Some heat can be generated actually from this reaction at the cathode, and also at the anode some electrons are released. Those electrons actually we can utilize them in the external circuit in this case in order to have source of electrical power that we can drive the electric vehicle. And this is the idea of the fuel cell electric vehicle in this case. This is the reaction, Shabab, at the anode. Hydrogen is ionized to have protons, positively charged hydrogen, and some electrons are released. This hydrogen ion can pass through the electrolyte, which is the membrane, to react with oxygen and produce water vapor plus some heat. And then actually the overall reaction of the cell, oxygen is reacting with hydrogen, then we can have H2O in this case. Let's look at, Shabab, at the concept of operation for this hydrogen fuel cell. Let's look at how it can work. So, Shabab, I will stop sharing and I will share again to include the computer audio. So here is it.
Hydrogen fuel cells.
Do you hear the voice, Shabab?
Yes.
Let's hear this. So see the concept of operation of the hydrogen
Can be used for a wide range of applications, like transportation, material handling, backup power applications, etc. The conventional combustion-based technologies presently used in vehicles and power plants. It is an opportunity for the fuel cell to provide its benefits. Hydrogen is used to power the fuel cell electric vehicles (FCEVs). It exerts more efficiency over conventional engine vehicles, as it produces no tailpipe emissions, but only emits warm air and water vapor. Let's learn how a hydrogen fuel cell works. Do you know how a battery works? Yes, the fuel cells work like batteries, but they do not run down or need recharging. They can produce electricity constantly. Fuel cells can operate at higher efficiencies than a combustion engines and can convert the chemical energy in the fuel to electrical energy. A fuel cell is composed of two plates separated by an electrolyte membrane. One plate is called anode and the other is cathode. Hydrogen is passed through the anode while oxygen is passed through the cathode. At the anode, the hydrogen molecules are split into electrons and protons by a catalyst. The positive particle of hydrogen can pass through the membrane, but the negative particle cannot pass through it. However, atoms need an equalizing charge, and to achieve this, electron must change the path. That time, the electrons are forced through a circuit and generates electric current and heat. The end product of this reaction is water, H2O. At the cathode, the hydrogen protons, electrons, and oxygen combine to produce water molecules. Due to the lack of moving parts, the cells are highly reliable and its operation is silent. The hydrogen fuel cell is useful in the automobile industry also. Currently, there are several companies around the world working on the development of hydrogen cars. To learn more about the hydrogen fuel cell car, check out our next video.
So this is the idea of the hydrogen fuel cell. As you can see, it's a silent operation, and also it can approach efficiency much more efficiency compared to the internal combustion engine. We can have fuel conversion efficiency up to 85% in the hydrogen fuel cell, and it can produce electrical power in this case. And this electrical power, we can store it in the battery pack, and then we can drive electric motor to drive the electric vehicle in this case. And this is the future of the car, is to have actually the hydrogen fuel cell car. And this already, I think, as I told you earlier, we have gas station here for hydrogen, and we have Toyota already version. They have actually released different version of hydrogen fuel cell car. But the only limitation here, Shabab, is that the hydrogen fuel cell car, it needs actually constant source of hydrogen. So we have to have hydrogen fuel tank to supply hydrogen actually for the fuel cell, and we have to have refueling station. So we have extensive research actually is going on under hydrogen in order actually to ease the handling process of hydrogen and the storing of hydrogen. And also we can have, it will need some time until we have the infrastructure actually to have a hydrogen fuel cell electric vehicle. We have to have hydrogen refueling station with all required safety precautions. So once this actually is spread, then in this case, at this stage, we can have the hydrogen fuel cell. But we have, Shabab, hydrogen fuel cell car has already been produced, and we have some hydrogen fuel cell station are already distributed in the world, but we don't have many of them. As I told you, still also price is an issue. Hydrogen fuel cell, its price is still high. And also it requires hydrogen, higher pressure hydrogen fuel tank, which is also of high price. And still also the oil have a very competitive price, and this will delay actually this conversion process. So right now we are in the stage of hybrid electric vehicle. Then we will be moving to plug-in hybrid electric vehicle, maybe electrical vehicle. But when we go to the electrical vehicle, I think at this stage, the hydrogen fuel cell will take over it. So battery electric vehicle will not be actually much longer for operation. This is my expectation, because hydrogen fuel cell actually are much more efficient, and they are actually have lighter weight, and that will be actually, once we have the technologies by which we can store hydrogen safely, and it has actually lower price for the hydrogen fuel cell. At this stage, actually, hydrogen fuel cell will be the, and for sure, ya Shabab, for vehicles in this sector, the future or the top point actually in this field is the hydrogen fuel cell. even if we totally convert it to the renewable sources, of energy. Renewable sources can be used in the electrolysis process. We need to store this energy. So the best way actually to store the energy is through the storage actually in the form of chemical energy, which is the form of hydrogen, through the electrolysis process. So we expect also the water electrolysis process we have actually a lot of advancement in this field also as well for the storage of hydrogen for future uses. So the future شباب for the fuel for the electric vehicle, we expect the future actually over the top point to be the hydrogen fuel cell. The vehicle at the end should be driven actually by the hydrogen fuel cell. We have different kind, almost it's the time for the class. We have different kind of شباب for the hydrogen fuel cell. The main kind which can be used for in the transportation sector for the vehicle, which what we call actually the proton exchange membrane, in which we have solid electrolyte. We don't have liquid electrolyte, just we have membrane that can allow for the transfer of hydrogen atom to react with oxygen. And this is the most common type of fuel cell.